Hi, everyone, and welcome to Data Engineers Lunch number 47. Today, we have Junior Software Engineer at Anant, Stefan, speaking on Airflow on Kubernetes. And the organizers for this event are Rahul Singh, Arpan Patel, and myself, and we are always looking for new members, speakers, and sponsors. So if you or someone you know would like to speak at this event or sponsor this event, definitely reach out to us and definitely be sure to tell your friends. We are here every Monday and stream live on YouTube. So you can send them that link as well. We are part of a larger community. Data Community DC is a diverse and inclusive culture, and we encourage and support people of all races, genders, sexual orientations. Everyone's welcome here, and we expect respect to be given to those classes. You can find out more about Data Community DC at their blog, as well as their upcoming events. What we cover here is everything related to data engineering. So this could be sources, ETL and cleansing to end user establishment or enablement of that data. At this point in the introduction, if anyone is new and would like to introduce themselves, feel free to do so. Some group rules. If you have a question, please ask it, be polite and courteous to others, and share what you know. This is meant to be a discussion. And here at Anant, we deal with real-time data and analytics platforms. So data engineering is a part of our daily life, and we're happy to bring you this webinar every week. DataStax is also a partner, as well as George Washington University, and these are some of the other program sponsors, as well as organizational sponsors. And if anyone has any jobs, meetups, or hackathons, feel free to share. You can drop it in the chat or unmute yourself and let us know what you have coming up. One plug that we have here at Anant is we're always hiring for full or part-time data platform operators, engineers, and architects. You can connect with us at careers.anant.us. And some upcoming events, we have the next Data Engineers Lunch, Vizu, is going to be presented by, I believe it's their CTO, JP, as well as we have Getting Started with Amazon S3. You can find all of our events listed at anant.us/events. And with that, I can pass it off to Stefan.
All right, thank you, Josh. Give me 1 second. Can you hear me good?
Yeah, we can hear you.
All right, perfect.
And I can see your screen as well.
All right, perfect. Thank you so much. All right, so if anybody needs to ask a question, just you can totally unmute yourself and ask me. It's I don't mind stopping in the middle of presentation. Or if you're more comfortable, you can just post it in the chat. Okay, and for today, we're going to take a look at Airflow on Kubernetes. How to use Kubernetes to deploy Airflow, kind of how it works, how the pods get run, and what happens when we run DAGs on Airflow. So what is Airflow? First of all, Apache Airflow is one realization of the DevOps philosophy of configuration as code. Airflow allows users to launch multi-step pipelines using a simple Python object DAG. You can define dependency, programmatically construct complex workloads, and monitor scheduled jobs in an easy-to-read UI. This is kind of how it looks like. We'll take a look at that, the UI more in depth later. Why Airflow on Kubernetes? Since its inception, Airflow's greatest strength has been its flexibility. Airflow offers a wide range of integrations for services, ranging from Spark and HBase to services on various cloud providers. Airflow also offers easy extensibility through its plugin framework. However, one limitation of the project is that Airflow users are confined to the frameworks and clients that exist on the Airflow worker at the moment of execution. A single organization can have varied Airflow workflow ranging from data science pipelines to application deployments. This difference in use cases creates issues in dependency management, as both teams might use vastly different libraries for their workflows. To address these issues, we utilize Kubernetes to allow users to launch arbitrary Kubernetes pods and configuration. Airflow users can have full power over their runtime environments, resources, and secrets, basically turning Airflow into any job you want, workflow orchestration. So the Kubernetes operator, before we move any further, right, we should clarify that the operator in Airflow is a task definition. When a user creates a DAG, they would use an operator like the Spark submit operator or the Python operator to submit monitor Spark jobs or a Python function, respectively. Airflow comes with the built-in operators for frameworks like Apache Spark, BigQuery, Hive, and AMR. It also offers plugins entry point that allow DevOps engineers to develop their own connectors. Airflow users are always looking for ways to make deployments and ETL pipelines simple to manage. Any opportunity to decouple pipeline steps while increasing monitoring can reduce future outages and free firefights. The following is a list of benefits provided by the Airflow Kubernetes operator. Increased flexibility for deployment, flexibility of configurations and dependencies, and usage of Kubernetes secrets for added security. This is the basic architecture of the Kubernetes operator. To generate the request is processed by the API server. Kubernetes will then launch your pod with whatever specs you defined. Images will be loaded with all the necessary environment variables, secrets, and dependencies, enacting a single command. Once the job is launched, the operator only needs to monitor the health of track logs. Users will have the choice of gathering logs locally to the scheduler or to any distributed logging service currently in the Kubernetes cluster. Okay, so let's jump in and start taking a look at this. First of all, there's a few different ways you can do this. I'm running Minikube, and I'm going to run this demo on Minikube. I've seen also on the Apache Airflow, here, let me drop that in the chat. They also have their own scripts, ready scripts that you can just use, and it will run Airflow also. Just straight up run the Airflow on a Docker container using Kind. So they're using Kind, not Minikube, but because I'm already I've been using Minikube for a while now. That's what I'm going to use. I'm running this on Docker. So Minikube is running on my Docker container. Sure. That's really fine, right? All right. Okay. So we have a few YAML files that I'm going to go through each and every one with and kind of explain the thought process here. But before that, let me just see if I'm in the right place. Okay. So whatever this script applies, it just runs all the YAML files. So while we wait for this to run, wait, that was pretty fast. Okay, let's go through these YAML files and see what's going on. The first one is so let's explain this. I'm using a Docker image to run this. And if you want to be more customizable, you can actually create your own Docker image with your own specifications. But just because for this demo, I'm going to use this Docker Docker Airflow image to run, and we can specify requirements using a text file, and we'll create a volume for the text file, and I'll talk about that a little bit later. But we have two config maps. So one is for the text file, and then the other one is for the environment variables. Let's go to the environment variables and see which each one of them is. Obviously, the first one is the executor. We need to set this one dynamically. Set the Airflow executor. The Docker image entry point script uses the environment variable to set the Airflow executor configuration. Then we have the Postgres information, the Postgres environment variables, obviously like the host, the user, password, the database, and the port. LoadX, I believe this is for the example DAGs that they come with with Airflow. So you can, I said yes or no to this. And we're going to take a look at one of those examples later on. And then we have these environment variables. So the first one is something to do with the Docker image. When I was doing it, the Docker image kind of like was throwing an error. So these here were set there. Let's go. So the tag, this is the tag, right? This is the repository. This is the volume host, because we'll be hosting our DAGs into a volume, a local storage directory volume, right? And then volume claim. This environment variable specifies the Kubernetes volume claim to use storage and read logs. And the config map reference, this specifies the name of the config mag that stores the environment variable. This will allow workers to load environment variables from the config mag when running. Okay, so let's move on to volumes. We have three volumes for this demo. We have the volume for the config map. We have the volume for the DAGs, and we have the volume for the logs. Let's see what else. So yeah, we can see that the volumes is a directory. So this is where we can store the DAGs, but this is in the cluster, not the host machine. And then let's take a look at the Postgres service. I mean, it's just basic service, the ports and the app, the deployment sets how much replicas, how much resources we're going to give. Obviously, if you're running this like locally for development purposes, you don't need that much. I guess if you're running this on production, you might want to like give it more resources, or depending how much you need. We're setting up the environment variables right here. Then we have the web server service. Again, we're saying the port and other stuff here. That let's take a look at a little bit more in depth here, right? The type node port. This means this will allow us to expose the service port, so we're able to connect to the service from our machine. And the port, the selector, this will be used by the service to identify which pods should receive traffic sent to the service. We took a look. So let's take a look at the deployment here. We can kind of see like the schedule and the web server are pretty much the same thing. Just the arguments are going to be different since we're using the image, the Docker container image. Anyways, again, we have some resources here. The environment variables are going to come from a config map reference, and then we have volume mounts, and then the volumes. We define the volumes, and then we mount them. Right, the volume mounts here, and all the three volumes that we need for this to work. And let's see, did we skip something? Oh, so this is also giving permissions to Kubernetes to run the pods, create pods while the DAGs are running. This is going to give the permissions to create pods and then delete them, right? I think basically that's the gist of it. Let's try and open it up. So we have, this is how the Airflow UI looks like. I think this is like an older version of it, but we can specify the tag in the YAML file, and we can probably use an old, newer version. I know this one kind of looks older a little bit. And if we go to exactly like, let's say this one, right? We can see the tree view, we can see the graph view, how it looks like, right? So if you guys, like if you have some complex data pipelines, you can kind of visually see how they look like, the duration, and actually let's just run this. Let's go here. just run this back, and we can see how. So in the meantime, while this is running, we can actually open up a new one here. CTL. You can see that right now we have the tree, the scheduler, the web server, and the database. But once this DAG starts running, there should be more should be created. And at the end, when the DAG finishes, they get deleted. Let's see. This one. Running, but okay, as we can see now, yeah, this creates a little bit more. So whatever this is doing, the tasks, they're creating a pause for every task, and then it's creating, and then at the end it's just deleting them, which I thought was pretty cool. I didn't know that's how it worked, but so we can kind of see, is this like the main example result, and then we can see in the graph view here what's getting done, what's not. This will kind of like fail at the end. So we can kind of look at the logs of whatever's happening, right? And we can see this one was successful, I guess, right? Let's see maybe something that failed. Search catalog, right? You can view the log here. You can see what happened. It's basic airflow stuff, right? The only difference is, right, this is running on Kubernetes. And yeah, let me see what else was I supposed to tell. Okay, let me see if this finished. And as we can see, only the scheduler, the web server, and the database are running in the background, while everything else that was completed is just deleted. And so, yeah, let me see. Yep. Does anyone have any questions? Wants to add something to this?
Can you try bringing up one of the? You said this is an older version of Airflow. So which Airflow version is this? And let's try it. Oh, this is way old. It's 1.0.
Mm-hmm.
Probably not use 1.0 ever, because it has a lot of security issues.
Yep.
Yeah. 2.2, and it's actually I think 2.3 at this point. So
also we can kind of look at, let me see, what was it? Okay, right, Airflow. So this is kind of like the GitHub repository from Airflow, the one that I dropped in. Let me see if I dropped that in chat. Restartability in Airflow DAGs. What do you mean? Like, can we restart the DAGs? We can retry. So, like, if it failed, I can like retry the DAG. If there's a failure in the step. Well, if there's a failure in some part of the DAG will fail. I mean, you can still again retry it again, restart it again, retry it again. I guess but I guess it probably will fail again if like something didn't change. But you can so you can just look here, and you can see how many runs success failed. And if you want to run it again, you can run it again. You can. I don't think you can do the same one retry, but like simply right, you trigger the DAG, and that's a retry, I guess, right? Also, so this is the, let me drop this in chat. This is the Airflow. Can you guys hear me now?
Yeah, we can hear you.
This is the GitHub repository for Airflow, and if we go to scripts, and they provide us with some scripts here that we can use to run Airflow as well. And like I said, this is a little bit different because this uses kind to deploy it, and this will create 2 containers and then run it in the containers. So let's try that out. Let's see. So see, it uses this non-image, right? They also have like scripts for testing, helm upgrades and stuff like that. I don't know if this is going to start though right now. Oh, as you can see, so here, these created 2 containers on my Docker. And inside, this is the control plane, the worker, right? Kind of like a different way of deploying it. I guess this is pretty easier. You just run the script and you get everything. But I think I was going into a problem with this one, though. Let's see this one launches right now. Thank you. I mean, while we wait, if somebody like has something to ask or like has anything more information to give us on like running Airflow or Kubernetes and stuff, feel free, because I don't know how much long this is going to take. I don't believe that much, right?
So let's say that you have a directory where you have all of your DAGs, like you're migrating it from a VM based Airflow instance to Kubernetes. Is it implied that it'll automatically create those containers for each of those jobs, or can we take a look at the DAG that you ran? Like, I want to see what the operators are. Are those like run this container on this Kubernetes cluster? Is that the operator, or is it just standard Python code that is being wrapped and run in Kubernetes?
Hold on, because these come directly from Airflow. So let's see if that's I think both can work, right? Minikube and this, because they're on separate containers, except for the port, maybe. That's going to be probably the problem while this is running in the background. But it's kind of like ran fast now. It's taking a little bit longer. So this one I ran, let's see code. Python operator, right?
Yeah, so let's see. Can you zoom in? Nobody can see that.
Yeah, sorry. My hand's getting big. Is it good?
Yeah, so this looks like it's bash. All of these are bash. So let's keep going down.
Delete. Look up, rename, search, update, entry tag, create tasks.
Yeah, so it looks like it's and I have to dig deeper, but it looks like it's running these in the different containers, but it's just running that specific task, meaning like, you know, it's running these echoes on different containers, I guess.
I haven't looked into the data much, but
because when you showed the containers getting created and getting destroyed, basically, I was thinking that it's saying, you know, run this container, which is a way to do DAGs, is you have your workload defined as jobs inside a container, and then you're just telling Airflow to run the different jobs, right? Because Kubernetes has a job engine where you can say run this, and Airflow integrates with that. Can we take a look at another one?
yeah.
Might be easier to take a look at it in your Visual Studio Code if you have that.
So I don't, because they're loaded in, and I don't really have them on my local.
Oh, okay.
So
You mean they're in the containerized Airflow?
yeah. So like I think where was this one that said you can just like load some example ones. Was it in the environment variables or something? Yeah, this one. I think you just like load examples and then just loads them. I'm assuming they're in the container itself, right?
Well, they get put in the container, so they're definitely in the Airflow repository. But so let's take a look at let's see, is there one just called Docker? I think there's a Docker operator as well, or no? You can do a Control F and look for the word Docker.
Yeah.
Okay, so no. What about Kubernetes? Oh, there you go. Search. Go into the search that's built into it. Okay. And what about Docker? Try Docker, because it may be on a different page. Okay, so let's go back to the main screen and let's take a look at the Python operator, for example. And if we take a look at the code. Yeah, so I mean, I guess we could run another cycle of this particular one to see what containers get created. But it seems to me that it is wrapping it and just running a container with that code. Okay.
Yeah, sure. Here, let's do this. We can start this one. We have 3 ones here running, so let's trigger this one.
You might have to do Control Z. Sorry, Control 0. to get it back to the default size. Because
This.
yeah, I don't know what you were trying to do, but
I'm trying to like put them in the same so we can see like when they're executing and which ones are running.
yeah, you can always switch back and forth. I think it's just worth running it a few times and see what it happens.
So, like, I guess it hasn't started yet, right? Print the context slip for 2.
So I think the Python operator is just running on, I mean, unless you're looking at the wrong Kubernetes cluster, I'm thinking maybe let's run the complex one, see what happens.
I guess what is this? I think it just like sleeps for it waits a little bit and then sleeps.
Well,
Or
it sleeps for like 5 seconds, so that it should be showing up. So let's run one of the complex ones and then go back to the home. Yeah, the DAG home. And let's run the complex one.
you run both in the same instance? I'm assuming yes, right?
So let's do your kube get pods, all right? So you want to see if it's doing anything. Okay, so example complex create entry group. That's what it's called. So if we take a look at the code for create entry group.
Copy this.
In your browser on the go to code and then look for the create entry group. Okay, so create entry group, there we go. That's where it started. And then maybe later down you'll see create entry GCS result. Yeah, so that's what's happening, right? It's taking every operator and it's wrapping it in the container and it's running just that part. So the way it's able to do that is every container has the full code. Otherwise, it wouldn't be able to do it. And it's basically saying to the container, run this part of the code, run this part of the code. So that's how it's doing it. So, but this is which version are you looking at?
This is still the one create a minikube. The other one, let me see if they're launched.
Yeah, so likely some of this has changed.
Yeah, so the difference is because kubectl points to my minikube, but these ones are kind of created in a container itself, like these two, and inside to use kubectl with this deployment, I have to go to the CLI of that. Let's see. So actually no. kubectl. It's probably careful, right? I probably crashed while it's kubectl. False. So the kind of crash to back off. I think maybe because they were both running on the same. I mean, I had already the other one running. This one doesn't start. false. So this one is the one from the airflow. And the pods here run, right? Wait, false. Should I see the error here somewhere? Yeah, it doesn't matter. Doesn't matter. So I think yeah, it kind of crashed. I didn't want to load, probably because I'm running the other one as well. I'm thinking, but yeah, I think this one is. I think I will launch this one. I think this one is the newer version of Airflow, that they like the latest version of it. Let me take a look at that. But these scripts are just kind of like undescriptive. I guess we can really use. So it's kind of, is this, so I think this is kind commands, right? And it's running kind commands, and then it's running probably starting the containers and doing everything in it. Web server hosting, probably. Also kind of cluster configuration. Let's see like the volumes, system volume. Yeah, I think this one is a little better one, but it's good because they built it. For some reason though, it's crashing now, and it takes like 5 minutes to build anyways. Anyway, yeah, does anyone else have any questions?
Thank you.
Thank you, everybody.
Thank you. Have a good one.
Thanks, everybody.